Awesome. Thanks, Lauren, and thanks everybody for joining this last big section. So I am going to talk about an overview of planting and post-planting activities. And some of you have seen parts of this before. I would say all of you have got some working knowledge about this, but I think it's important to reiterate a lot of the messages that I'm going to discuss today. There is a different type of group that I give this presentation to that doesn't have that working knowledge, and it's not moving. There it is. And I called the title of this slide "Green Side Up." I feel like we're a bit more advanced than that group. So we're going to get a bit more technical, nerd out, have a little bit of fun. And please don't tell the authorities. I want to keep my job. So we have seen this reforestation pipeline many times before. It's funny because Josh, Jeremy, and I have been working together for a long time. So you'll probably see some of the same figures and some of the same things over and over again. But I think that's important because it's just reinforcing those messages. And so, Josh was talking about seed. Jeremy was talking about the nursery. And I'm going to be talking about the outplanting, post-planting activities. And I think it's really important to point out that we have to invest in the entire pipeline. And so there is a ton of money and resources that goes into seed collection, seed processing, and seed banking. Josh knows this very well. Same story with the nursery. And so if we let go of the handlebars and, kind of give up at that outplanting and even at the post-planting, we may lose that initial investment. So it is really important that we invest into the entire pipeline. I think you guys have seen this one before too. But the target plant concept is going to come back up again and again. And it is an important concept. And, my focus is going to be on these two last elements here regarding the outplanting. But you'll see throughout that what I'm going to talk about connects with all other elements of the pipeline. And today, I want to give an outline of what I'm going to talk about. And it is, just like everybody else, we don't have a lot of time. So it's a 30,000-foot view of what is important in the outplanting and post-planting activities. So we're just scratching the surface, and some of these things we could probably spend an entire semester talking about. But I felt like the best way to give this outline is through a timeline. And you would think it would start with tree planting, but it actually starts with many, many, many things that happened prior to that. And so I'm going to be talking about site evaluation and planning, site preparation, nursery production, seedling transportation, on-site storage, the actual action of planting the trees and planting techniques, animal protection, inspections, monitoring and data collection, post-planting silvicultural treatments, the potential need to replant, and additional monitoring and data collection. And finally, we get to a point where seedlings are free to grow. So let's start with site evaluation and planning. And so with the initial site evaluation, we can do certain things remotely. We can characterize the sites in terms of what are the native seed sources, what are some of the climate patterns, soil characteristics, what's the competing vegetation, slope aspect, animal pressures. We can ask the question of, does it need to be planted? So is there potential for natural regeneration? What's the size of the disturbance? And then what do the planting models suggest? Right now at the University of New Mexico, we got Dr. Marsh and Herto that are working on a model that is using input variables such as solar radiation, precipitation, topography to kind of look at a microclimate for the individual seedling, which then translates to a seedling survival probability map. It's still in its infancy, but there's a lot of promise and the research is ongoing. And then you can ask the question is, what is the likelihood of planting success? And this helps us rank against other sites for prioritization. it is very likely that you're going to have a lot of planting needs and not enough resources to do all that planting work. I think it's very important that we get out onto the site and do our initial site evaluation. It helps us confirm those site characterizations, getting out there and testing the soil. I like bringing out a planting shovel and just kind of exploring what that root zone is like in terms of that soil profile that Jeremy had kind of talked about before. And it's important to assess the site preparation needs, and I'm going to discuss a little bit about this later on. And then access logistics. How are we going to get the planting crews and equipment out there? And so based on that site evaluation, both the remote and on-site, we can begin planning. And so I know that Jeremy's already mentioned the planting season or that planting window. And for us, it's important that when we plant those seedlings, we need to match that with the highest likelihood of success. And for us, especially in the Southwest, that's when we have the highest soil moisture. And it may not materialize, so it's good to have a plan B. And you're going to see this over and over again, but it's important to work with the nursery on your plans. And so I'll talk about this a little bit later on too. Current research in the Southwest is showing that ideal times to plant first starts with the monsoon when we have the highest soil moisture, followed by the fall, followed by the spring. However, there's nothing consistent about that. I have seen really wet springs and extremely dry summers with no monsoon. So again, that's why it's important to have that plan B. Planning your planting material. So what is the target species you want to put back on that landscape? And Josh, went into a really good detail on seed source. And so what is the seed source that we need that will work best? Are we going to be integrating assisted migration into this planting program? The planting design. So what is the density at which you're going to plant the trees per acre? How are those trees going to be oriented across the landscape? Is this in a nucleation fashion, random or variable or gridded? And then I think it's important to figure out your planting logistics, how we're going to move our trees from A to B and everything in between. And I'm going to go in more detail on this a bit later on too. Some other things that need to be considered that are very important. One, it may be required for NEPA clearance or cultural surveys, especially on federal land. I think it's very important that you have to build a budget for all activities. And honestly, I think if you can, that goes all the way back to, Josh's talk about seed collection. And then that carries all the way forward to the post-planting activities. And one thing that, we need to spend a lot of time talking about, but this is just the one point I'm making today, but securing planting contractors and, try to do that as early on as possible. So now I'm going to talk about site preparation. And I think Colin had some, conversations about veg control versus taller trees and things like that. And there's a lot of debate and discussion on that, but there may be a need to get out there and control the competing vegetation. And there's different means of doing that. And it's also, important to note that we may be going into a post-fire site that's 5-10 years old. And so you've got some really established gamble oak, for example, that will likely outcompete whatever you plant. So there is going to be a need for some level of control. And pocket gophers have decimated many of my research plots. And so this is a big problem. And so trapping may be necessary to protect those trees before you plant. There may be a need to control and manage the snags and woody debris, and that could be through salvage logging or pile burns. And honestly, elk and deer to me have just been the biggest problem for a lot of my planting sites. And so there's preventative measures such as damage control hunts or animal deterrents like air cannons that can be placed before we even start planting. So at the same time that a lot of the site prep work is going on, we can start our conversations with the nursery. And so, Jeremy showed a slide about timelines and how long it takes, but the key is to place orders well in advance, at least a year prior to planting, and it may be a lot more than that. We may not even have the seed, and so this requires you to call Josh up and He's got to climb up on that tree and start collecting cones. You need to know how much you need and put in a buffer, both for the nursery and for yourself. Of course, working with the nursery to figure out the species. And then again, the stock type, what Jeremy kind of talked about too, in terms of different sizes, what we can do in terms of conditioning, and all those things need to be planned out well in advance. And then with the planting window, again, it goes back to working with the manager. That is when how we determine when seeds are sown. And so if you're planning for a monsoon and it doesn't materialize, it may be that you have to plant in the fall. And so having that plan B is really important. And then again, working with that nursery manager, that communication is key. Have them provide you updates on how the crop is performing, and vice versa. If you're seeing changes in your planting plan, you need to be working with the manager for that plan B option. So I want to briefly talk about stress to seedlings, because this is really important. And from the time that seedlings are harvested or lifted from the nursery to the time they're planted, they can be subjected to a variety of different types of stresses. So in this table here, you see on the left, different processes. You've got nursery storage, handling, shipping, on-site storage, and outplanting, and you've got different types of stresses. You got temperature and desiccation, mechanical injuries, and storage molds. But one of the things that pops out is that temperature and desiccation are of major concern, and they all are. And I think what we want to do is kind of think of this from a checkbook kind of analogy. When we harvest our seedlings, when those seedlings are lifted from the nursery, it's best to think that they're in their most optimal condition. These are the highest quality that they're going to be. So our balance at that time is 100%. And any and everything that we do from that point to the time that we plant the trees can be subjecting them to some kind of stress. So that is a withdrawal from that balance of quality. And so our goal is to minimize it. You may not make it zero, but we can be preventative as best we can. And so the goal for us at the end of the day is to minimize that withdrawal and maximize that seedling quality when it goes into the planting hole. So with seedling transportation, again, you have to work with the nursery. So working on pickup dates and the schedule, don't pick up more than you need, because then there's seedlings waiting around that are probably going to get stressed. Ideally, the nursery has those seedlings well watered, so that moisture content in the plug is ideal. And know how they're being packed, if they're in containers or bags or boxes, because this gives you an idea of how you're going to stack them and put them in those trucks or trailers. The transportation conditions are also very, very important. In an ideal scenario, we want to be moving these seedlings in a refrigerated truck, in a refrigerated trailer at cooler temperatures. As we increase those temperatures, we decrease the quality of the seedlings. We also really don't want any wind. We don't want to dry out those root systems. It doesn't take much. So our goal is just to protect those seedlings. So the vehicles that we like to use in transportation of seedlings to a staging area would be refrigerated trucks or trailers as an ideal scenario, or covered trucks, a canopy, or like a cooler box. It's like the one in the photo here that Nabil provided, that just slides in the back of a pickup. But what you don't want to do is drive down the road like you see in the bottom photo here, with seedlings in the back of the truck. You got solar radiation just penetrating onto those boxes. You got the wind, and you're going to start chipping away at that seedling quality in that checkbook analogy. Another option too is if it's warm and you got a covered truck, you can drive at night. We've done that many times over long distances to minimize the stress to the seedling. So in terms of on-site storage, again, if there's an opportunity to use a reefer truck or a walk-in cooler, that would be great at the base camp. But when we get to the field site, we're going to be a bit more limited in what we can do. And so it's usually more of a passive system. And we really have to protect ourselves from those temperatures, from exposure to the sun and exposure to the wind. And in this graph right here, you can see with the yellow line, that is a no cover. So that's basically seedlings sitting out in the sun, and our temperatures are extremely high. And that will degrade the quality of the seedling pretty quickly. You put a canvas cover on top of it, and that's like a thermal blanket, and we're actually creating a bigger problem. So not an ideal scenario. What we found is space blankets and heavy shade work really well, but it's also important to kind of protect them from the wind as well. And so another concern that we have is for those seedlings to dry out. And it's good to kind of monitor that along the way. The graph that we have here on the right shows the plug water content, where we go from right to left. As it decreases, you're going to see a significant increase in mortality. So there may be a need for us to dip or irrigate those seedlings just prior to outplanting. I think it's going to be a lot easier for us to increase that water content of the seedling, at the loading area versus that of actually in the field. And then, another big concern is just the mechanical stresses that can happen with those seedlings, especially with the planting bag. So you don't want to overpack those planting bags. These are very fragile organisms, and it doesn't take much. If you look at the graph to the right, the control, if you look at the green bars, the control on the left, pretty large. But if you look in the middle, we have seedlings that have been dropped from a height of about 1.5 feet, and we see a decrease in volume growth of about 50%. Another thing that we can do when we're handling those seedlings in the field is use a reflective tarp or a space blanket for the tree planters if necessary. So I want to move on to planting techniques and especially planting tools. And I know Jeremy was talking about the target plants, concept about matching the seedling to the site. And so working backwards, if we're matching the seedling to the site, well, then we need to match the tool to the seedling to the site, right? And so for us, the ideal planting bar that we've been using here in the Southwest is the Jim KBC dibble bar. And it works really well because when we think about the planting method, ultimately our goal is to minimize soil disturbance. And, we were supposed to do this in person and do some demonstrations up on the hill to kind of talk about planting methods and techniques. So we'll use the figure as the proxy for that right now. But, the idea is we're basically putting in the dibble bar, you're prying open the soil, you're sliding in this container, the seedling, and you're closing up that hole. We are not pulling out soil and letting it sit out and being exposed to the sun, wind, and drying out. And I've seen that a lot with the Hodad. The Hodad works really well in good, soils, buttery soils of, the Oregon Western mountains. But here we're in the Rocky Mountains, and there's a reason why they call them the Rocky Mountains. So the Jim bar has been proven to be very effective in the work that we do, especially with the seedlings that we use. In terms of other planting techniques, we have microsite selection. For example, we can be looking at placing seedlings on the north side of logs, north side of stumps, north side of snags, and even in some cases on the north side of vegetation, so long as it's not going to be extremely competitive with the seedling being planted. Very important would be the installation of animal protection. Again, elk and deer tend to dominate what happens with our reforestation programs. And so we use a variety of different techniques, but here in the Southwest, we've been using the Vexar tubes, the bottom left, most commonly, but you've got a whole other slew of options, which can, we need to probably do some more research on, but you've got bud caps and these big, large tree tubes on the right. And this pocket gopher guy keeps showing up, but that is because they are problematic. And so at the time of planting, if we're seeing a lot of activity, again, it's important to consider trapping. So planting inspections are performed during the planting operation. And some of the things that we're looking at here are planting density, microsites, planting quality, making sure that, I think Jeremy showed a slide of a J-rooted seedling being planted. I think that was number 5 here on this figure. And shelter quality, making sure the shelters are installed properly. And it's important to do this throughout the planting operation because it's likely you're going to see some mistakes along the way. And you want to make sure that you can make those adjustments with the planting crew before it becomes too problematic. So next up, we have our post-planting activities. And first, we have our monitoring and data collection. And so in terms of the timeline for monitoring, it really begins at the time of planting. We should be putting in our first plots at the time of planting, and this can be incorporated into the inspections if necessary. And our second measurement should be after the first growing season, and then continue as often as possible. I know that the Forest Service will do it after the first growing season and after the third growing season. And the data to be collected is really important. Survival is obvious, but we need to also get some other characteristics of what's going on in terms of growth, for example, height and/or diameter, and also damage. Is there frost damage? Is there animal damage? And then I think it's also important for us to note all of that information about the planting, the seed source, the nursery that it was grown in, the stock type, the date, and those other things. And I do want to point out that the method that we collect this data is extremely important. And so ideally, we're trying to, just maximize the value of that data. So we want really strong, statistically valid data. Fixed plots are the best, but they just take a lot of work. It takes a lot of energy and resources to put those in. Transects work quite well as fixed plots and just maybe a little bit more cumbersome for the analysis. And stake rows have a lot of limitations, and I question some of the value that the data that it generates, and that data is really, really important. And the reason why is that data allows us to assess the performance of those seedlings and then help us refine the process within that whole target plant concept. So if we're seeing failures and we have good data, we may realize that it's a part of the nursery conditioning process or that it's a seed source issue. And so, if for us to continue to improve our reforestation efforts, we need good data. And based on what we're doing in terms of monitoring, we can also do some post-planting silvicultural treatments. For example, we can do release treatments with continued vegetation control. We may need to adjust and/or add tree protection. And this guy keeps popping up everywhere, but trapping is, a potential necessity because I have seen them wipe out so many plots. And you may need to fertilize. It depends on the soil, and that might be part of the site evaluation. But overall, it's really critical to apply a lot of these post-planting silvicultural treatments within the first 3 years when the seedling is most vulnerable. And it may be based on our monitoring and potential failures in our silvicultural treatments. It may be necessary to replant. And that might be to meet certain objectives such as stocking levels. I think it's important to determine what factors contributed to that failure. We can adjust our plan using those limiting factors. And then we can start the whole process over. Start with the site evaluation, planning, nursery production, etc. And then we go back through and do the entire seedling assessment performance and refine the process. And ultimately, and you've seen this slide before from the nursery side, but it works very well with our outplanting side too, is we're trying to create that positive seedling feedback loop. And our goal is to minimize disruption. So for example, if we're seeing animal browse on the shoot, we're decreasing photosynthesis, which then translates to a reduction in new root growth. And another example is if we're driving those seedlings down the highway and we're drying out the roots and we lose the ability to, move water from the roots to the shoot, well, then we're not putting on new shoots and decreasing photosynthesis. So if we can minimize our disruption, we can have continued growth and survival. And then we finally get to the point where we are free to grow and we have success.